Good morning, my dear students. Today that is a video clips. That is the electric potential energy possessed by the system of the two charges. Already in previous year, that is in first PUC, you know about the work, energy, power. You know about the work done. You know about the energy. When you derive the expression for the potential energy and kinetic energy, finally you have to take this here. Work done is equal to what you say, that is the energy. Work done is equal to energy. The work is done is always by the application of the force. Work done by the application of the force. In the case of gravitation field, this is by gravitation force. By the gravitation force, work is done. Whatever the energy stored in that body, that is said to be gravitation potential energy. Now, gravitation chapter nolaga gravitation force ತಗೋತೀವಿ. ಆ gravitation force ನಿಂದ ಬಾಡಿ ಮೂವ್ ಆಗಿ ವರ್ಕ್ ಡನ್ ಆಗುತ್ತೆ. ಆ ವರ್ಕ್ ಡನ್ ಆಗಿದ್ದೆ ಅದು ಎನರ್ಜಿ ಆಗಿರುತ್ತೆ. ಆ ವರ್ಕ್ ಡನ್ ಈಕ್ವಲ್ ಟು ಎನರ್ಜಿ ಅಂದಾಗ ಅಲ್ಲಿ ನಾವು ಗ್ರಾವಿಟೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ತಗೊಳ್ತಾವೆ. ಬಟ್ ಹಿಯರ್ ಇನ್ ದ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ಸ್ ದೇರ್ ಇಸ್ ಎ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಆರ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್. ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ನಿಂದ ಏನಾಗುತ್ತಾ ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ. ವರ್ಕ್ ಡನ್ ಆಗಿದ್ದು ಎನರ್ಜಿ ಆಗಿರುತ್ತಾ. ಆ ಎನರ್ಜಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ. ನಾವು ಸಿ the electric potential energy by the system of the two charges. ಅಂದ್ರೆ ಒಂದು ಚಾರ್ಜ್ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ತಕೊಂಡು ಬರೋದು. ಈಗ ಇಲ್ಲಿ ಇನ್ ದ ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ತಗೊಳ್ಳೋಣ ಮೊದಲಿಗೆ ನಾವು. ಇನ್ ದ ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಇನ್ ದ ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ತಗೊಂಡು ನಾವು ಹೊರಗಡೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲ. ನಾವು ಚಾರ್ಜ್ ಇಸ್ ಪ್ಲೇಸ್ ಅಟ್ ಪಾಯಿಂಟ್ ಎ ಬಿಗಿನಿಂಗ್. ಈ ಚಾರ್ಜ್ ಪಾಯಿಂಟ್ ಎ ದಾಗ ಐತಿ ಅಂತ ತಿಳ್ಕೋಣ. ಅವಾಗ ಏನಾಗುತ್ತ ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಎ Q1 ಚಾರ್ಜ್ ಇಂದ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಬರುತ್ತೆ. ದಟ್ ಇಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಟ್ ಬಿ ಡ್ಯೂ ಟು ದ ಚಾರ್ಜ್ Q1. ಇಲ್ಲೇ ಇದರಿಂದ ಎಷ್ಟೋ ಪೊಟೆನ್ಷಿಯಲ್ ಬರುತ್ತೆ. ದಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಯೂಸೆಡ್ ಟು ಬಿ V1 is equal to 1/4π Q1 divided by R. ಯು ಸೇ ಇಕ್ವೇಶನ್ ನಂಬರ್ 1. ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಈ ಚಾರ್ಜ್ ಇಂದ ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. Now, electric potential energy possessed by Q2 due to Q1. ಅವಾಗ ಏನು ಮಾಡೋದು, Q2 ಅನ್ನೋ ಚಾರ್ಜ್ ಅನ್ನ ನಾವು bringing from the infinity distance to this point. Now, when it is placed at this point, that energy U is equal to potential energy into charge. How you got? You got this is like this. Potential is equal to work done divided by Q. Now, work done is equal to Q into P. Now this is the potential energy. Now it is Q into V. Work done is the same as the potential energy. ಅಂದ್ರೆ work done ಎಷ್ಟು ಇರುತ್ತೋ ಅಲ್ಲಿ ಎನರ್ಜಿನೂ ಅಷ್ಟೇ ಇರುತ್ತೆ. That energy is equal to charge into the potential at that point. ನಾವು ಹೀಗೆ ತಗೋಬಹುದು. ಇನ್ನೊಂದು ಟೈಪ್ ಹೇಳ್ತೇವೆ ನಾವು. ಈಗ ಇದೊಂದು ಚಾರ್ಜ್ ಇನ್ನೊಂದು ಚಾರ್ಜ್. ಇದು ಇನ್ಫಿನಿಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ಇದನ್ನ ತಗೊಂಡ್ಬರೋದು. ಅದನ್ನೇ ಇನ್ಫಿನಿಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ಇದನ್ನ ತಗೊಂಡ್ಬರೋದು. ಅವಾಗ ಈ ಒಂದು ಸಿಸ್ಟಮ್ ತಗೊಳ್ಳೋದು. ಅವು ಒಟ್ಟಾರೆ ಹಿಂಗ್ ತಗೊಂಡು ಬರ್ಬೇಕಾದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ ಅದಕ್ಕೂ ನಾವು ಏನಂತೀವಿ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಸ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಪೊಸೆಸ್ಡ್ ಬೈ ದ Q2 ಡ್ಯೂ ಟು Q1 U is equal to ಪೊಟೆನ್ಷಿಯಲ್ ಅಟ್ ಬಿ ಇಂಟು ಚಾರ್ಜ್ Q2. ನಾವು ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿದೆ ಇಂಟು ಯಾವ ಚಾರ್ಜ್ ತೊಗೊಳ್ತೀವಿ ಅಲ್ಲಿ ತಗೊಳ್ತೀವಿ ಆ ಚಾರ್ಜ್ Q2. 1/4π Q1 divided by R into Q2 ಆಗುತ್ತೆ. Then electric potential energy 1/4π Q1 into Q2 divided by R. This is the expression for electric potential energy possessed by the system of the two charges when separated by the distance R. ಈಗ in presence of electric field ನೋಡೋಣ. ನಾವು ಇದು absence of electric ಹೊರಗಡೆ ಫೀಲ್ಡ್ ಇದ್ದಿಲ್ಲ. In the presence of electric field ನಾವು see in presence of electric field. ಈಗ electric field ಇದೆ. In presence of electric field, how you got? Now the charge is bringing from infinity distance to this point. At that what time work is done? That work is done divided by charge. That is said to be potential. Work done is equal to Q into V. This is the potential energy. Q into V. Therefore, Q into V. Yes. Now, whatever the charge here, whatever the potential here, into whatever the charge which is placed at this one, you got the electric potential energy by the single charge in the presence of electric field. In the presence of electric field, ಒಂದೇ ಚಾರ್ಜ್ ನಿಂದ ಬರ್ತಕ್ಕಂಥ potential energy. ಸರಿ, ಇವಾಗ by the two charges, already electric field is there here. Electric field ಇದೆ. ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಎರಡು ಪಾಯಿಂಟ್ ತಗೊಳ್ತೀವಿ, ಪಾಯಿಂಟ್ ಎ ಪಾಯಿಂಟ್ ಬಿ. ಪಾಯಿಂಟ್ ಎ ಮತ್ತು ಪಾಯಿಂಟ್ ಬಿ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ದೂರದಲ್ಲಿದೆ, ಅಪಾರ್ಟೆಡ್ ಡಿಸ್ಟೆನ್ಸ್. Now you bring the Q1 from infinity distance to this point, whatever the work done, W1 is equal to Q1 into V1 according to this one. When you are bringing the charge from infinity distance to the point B, at that time work done W2 is equal to Q2 into V2. ಹೌದಾ? ಆಮೇಲೆ ಇದನ್ನು ಎರಡು ತಗೊಂಡು ಬಂದ್ರಿಂದ ಒಂದು ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ನಿಂದ ಇನ್ನೊಂದು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತೆ. W3 is equal to 1/4 Q1 into Q2 divided by R, equation number 3. Now potential energy possessed by all the three charges, all the two charges, when placed in the electric field, U is equal to W1 plus W plus W3. U is equal to Q1 V1 plus Q2 V2 plus 1/4 Q1 into Q2 divided by R is the expression for the electric potential energy possessed by the system of the two charges in the presence of what you say electric field. Now, what is the meaning of that is the electron volt? Electron volt. Now, here the electron volt, one electron volt, that is the energy, is the potential energy is 1 electron volt. What is the meaning of? That is the potential energy of 1 electron volt. Now, with the help of this expression, see here. With the help of this expression, U is equal to Q into P. Yes. What is said to be 1 electron volt? Now here, U is 1 electron volt. 1 electron volt is equal to. Now, this is 1 coulomb into 1 volt. 1 coulomb into 1 volt. Now, 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. 1.10 to the power of 1.6 into 10 to the power of minus 19 joule. What is 1 electron volt? It is the amount of energy gained by an electron when it is accelerated through the potential difference of what you say 1 volt. That is said to be 1 electron volt. The potential difference, how do you take here potential difference? Now that energy is equal to charge into potential difference. Potential difference ನಾವು ಎಷ್ಟು ತಗೊಳ್ತೀವಿ? 1 volt ತಗೊಳ್ತೀವಿ. 1 volt ತಗೊಳ್ತೀವಿ. This is said to be 1 electron charge here. Now here 1 electron charge here 1.6 into 10 to the power of minus 19 into this is a 1 volt. This is equal to 1 volt. Now this is the charge here coulomb. Now is the 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule here. Therefore 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. How you define 1 electron volt? The 1 electron volt is the energy gained by an electron when it is accelerated through the potential difference of 1 volt. Thank you. Good morning, my dear students. Now in this video clip, there is electric potential energy possessed by the system of the three charges in the absence of the external electric field. Already you know that is the electric potential energy possessed by the two charges. Suppose this is the one charge, this is the another charge. Suppose this is Q1, this is said to be Q2. Now distance between these two is r. Then the electric potential energy 1 by 4 pi epsilon naught q1 into q2 divided by ra. Now electric potential possessed by the system of three charges in the absence of the electric field. Now see here. ಈ ಮೊದಲು ಏನು ಮಾಡೋಣ, Q1 and Q2 ಅಷ್ಟು ತಗೊಂಡು ಇದು ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಸಿ ಇಲ್ಲಿದೆ, ಬಟ್ Q3 ಇಲ್ಲ. ಅವಾಗ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಪೊಸೆಸ್ಡ್ ಬೈ Q1 and Q2 ಇದರಿಂದ ಅಪಾರ್ಟೆಂಟ್ ಡಿಸ್ಟೆನ್ಸ್ here R1 here. At that time the electric potential energy possessed by Q1 and Q2 is U1 is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R1. You say equation number 1. ಈಗ ನಾವು ಪಾಯಿಂಟ್ ಸಿ ತಗೊಳ್ಳೋಣ. Point C at distance R3 from the A. Point C at a distance R2 from the B. Then what would I take here? And Q3 is bringing from infinity distance to this point. Before going to that one, what is the electric potential at this point? Due to these two charges. Due to these two charges, electric potential ಇಲ್ಲಿ ನಾವು Q3 ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಫಸ್ಟ್. ಅವಾಗ electric potential at this point is equal to 1 upon 4 pi epsilon naught Q1 by R3 plus 1 by 4 pi epsilon naught Q2 by R2. ಇದು ಈ ಪಾಯಿಂಟ್ ಸಿ ನಾಗಿರತಕ್ಕಂತ ನೆಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವ ಚಾರ್ಜ್ ಇಂದ, Q1 ಮತ್ತು Q2 ಚಾರ್ಜ್ ಇಂದ ಬರತಕ್ಕಂಥದ್ದು. ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ. ಆಗ ಈ ಪೊಟೆನ್ಷಿಯಲ್ ನಲ್ಲಿ Q3 ಚಾರ್ಜ್ ತಗೊಂಡು ಬಂದಾಗ work done when bringing the Q3 from infinity to point C, ದೂರದಿಂದ ಇಲ್ಲಿ ತಂದಾಗ ಟೋಟಲ್ work done here U2 is equal to P into Q3. ಇಲ್ಲಿರೋ ಪೊಟೆನ್ಷಿಯಲ್ ಇಂಟು ಇಲ್ಲಿರೋ ಚಾರ್ಜ್. U2 is equal to ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಪೊಟೆನ್ಷಿಯಲ್ V 1 upon 4 pi epsilon naught into Q1 by R3, 1 by 4 pi epsilon naught Q2 by R2, now into what you say Q3. Now 1 upon 4 pi epsilon naught Q1 into Q3 divided by R3 plus 1 by 4 pi epsilon naught Q2 into Q3 divided by R2. Then total potential energy. ಮೊದಲ ಈ ಚಾರ್ಜ್ ತಗೊಂಡು ಬಂದು ನಾವು ಸಿಸ್ಟಮ್ ಮಾಡ್ಕೊಂಡಾಗ ಇಷ್ಟು ಎನರ್ಜಿ ಇತ್ತ, ಬಿಗಿನಿಂಗ್ ಎನರ್ಜಿ. Q3 ಪಾಯಿಂಟ್ ಸಿ ತಗೊಂಡು ಬಂದಾಗ ಇಷ್ಟು ಎನರ್ಜಿ ಬಂತ. ಅವಾಗ ಒಟ್ಟಾರೆ ಎನರ್ಜಿ, total energy, that energy is equal to the potential, beginning is energy ಇತ್ತು, yes U1 ಯಾವಾಗ Q1 and Q2 ತಗೊಂಡು ಬಂದಾಗ. ಆಮೇಲೆ Q3 ತಗೊಂಡು ಬಂದ್ಮೇಲೆ ಮತ್ತೆ ಇಷ್ಟು ಎನರ್ಜಿ, ಒಟ್ಟಾರೆ ಎನರ್ಜಿ U1 plus U2. Then 1 by 4 pi epsilon naught Q1 into Q2 divided by R1 plus 1 by 4 pi epsilon naught Q2 into Q3 divided by R2. ನಾವು ಮೊದಲ ಇದನ್ನು ತಗೊಂಡೆ ನಾನು, this one U1 ತಗೊಂಡೆ ನಾನು ಫಸ್ಟ್. U1 1 by 4 pi epsilon naught Q1 into Q2 divided by R1. ಆಮೇಲೆ ಇದು ತಗೊಂಡೆ. ಹೇಗೆ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು, ಈ ಟರ್ಮ್ ಮೊದಲಿಗೆ ತಗೊಂಡಿದ್ದೀನಿ 1 by 4 pi epsilon naught Q2 into Q3 divided by R2 plus next ಈ ಟರ್ಮ್ 1 by 4 pi epsilon naught Q1 ಬದಲಾಗಿ ಮತ್ತೆ Q3 ಬದಲನ್ನ Q3 into Q1 divided by R3. It is the electric potential energy possessed by the system of the three charges when they are in the form of triangle by the system of the three charges. Now this equation you have to write in the examination, ask in the examination question, is only for 2 marks. Now see here, either this one or this one, whatever it may be. Now from this expression now see here, unlike charge ಇದ್ರೆ Q1 into Q2 ಏನು ಬರುತ್ತಾ, ನೆಗೆಟಿವ್ ಬರ್ತದ, U ಏನು ಬರ್ತದ, ನೆಗೆಟಿವ್ ಬರ್ತದ. ಎನರ್ಜಿ ಏನು ಬರ್ತದ, ನೆಗೆಟಿವ್. ಎನರ್ಜಿ ನೆಗೆಟಿವ್ ಬಂದ್ರೆ now energy created, the potential energy possessed by the force of attraction. ಅಥವಾ ಲೈಕ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ Q1 into Q2 ಏನ್ ಬರುತ್ತಾ, ಪಾಸಿಟಿವ್ ಬರುತ್ತಾ, U ಏನ್ ಬರುತ್ತಾ, ಎನರ್ಜಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತಾ. Now this system of the charges possessed by the electrostatic, the force of ರಿಪಲ್ಷನ್ ಅಂದರೆ ಇಲ್ಲೇ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸಿಂದ ಬರ್ತಕ್ಕಂಥ ಎನರ್ಜಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ, ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸಿಂದ ಬರ್ತಕ್ಕಂಥ ಎನರ್ಜಿ ನೆಗೆಟಿವ್ ಬರ್ತದೆ. ಅದಕ್ಕೆ ಈ ಎನರ್ಜಿ ಏನಾಗಿರ್ಬೋದು, ಪಾಸಿಟಿವ್ ಬರ್ಬೋದು, ನೆಗೆಟಿವ್ ಬರ್ಬೋದು. ಇದು ಬೈ ದ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್, ದಿಸ್ ಇಸ್ ಬೈ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್. ಸಮ್ ಟೈಮ್ ಬರ್ದು ಜೀರೋನ ಬರ್ಬೋದು. ಅಂದ್ರೆ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ನ್ಯೂಟ್ರಲ್ ಆಗುತ್ತೆ, ನೆಟ್ ಫೋರ್ಸ್ ಜೀರೋ ಆಗುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ electric potential energy possessed by the system of the three charges in the absence of electric field. Thank you. Good morning, my dear students. Already in previous video clips, you know that that potential energy possessed by the system of the two charges, and potential energy possessed by the single charge in the external electric field, and the potential energy possessed by the system of the two charges in the presence of the electric field. Beginning by two charges in the absence of the electric field. Next, electric potential energy possessed by the single charge in the presence of the electric field. Then the system of the two charges in the presence of the electric field. And finally, electrical potential energy possessed by the system of the three charges when they are placed in the form of triangle. Now, when a dipole is placed in the electric field, at that time it is also possesses the electric potential energy. Dipole, the electric dipole. Now this is the negative charge of the dipole. This is the positive charge of the dipole. Minus q plus q separated by the distance 2a. O is the center of the dipole. Now it is placed in the uniform electric field here. Electric field is uniform here. Now the dipole moment of the electric dipole is 2a into q into p cap. Its magnitude is 2aq here. It's the dipole moment. When it is the turning effect of an electric dipole in the uniform electric field, already you know this one. Torque on electric dipole, tau is equal to vector p into vector e, p sin theta, question number 2. Small, now when the dipole is rotate from one position to the another one, what happens? There is a small work done. That work done is equal to torque into small angular displacement, that is set by d theta. It is in the rotation motion in the previous year, first year syllabus. Then dw is equal to pe sin theta, tau is equal to pe sin theta into d theta, equation number 3. This is for small angle of rotation d theta. When total work done for the orientation from theta 1 to theta 2, ಅಷ್ಟು ಆಯಿತು ಅಂದರೆ, now this is the total amount of work done, integration over theta 1 to theta 2 pe sin theta into d theta. Now w is equal to pe into integration over theta 1 to theta 2 sin theta into d theta. Integration over sin theta d theta is minus cos theta. Yes. Integration over cos theta is d theta is sin theta. Now here integration over sin theta is minus cos theta. Upper limit theta 2, lower limit theta 1. Now w is equal to p minus cos theta 2. Theta is upper limit theta 2 and you substitute, that is the lower limit. Now minus cos theta 2 minus of cos theta 1. Now the p is into bracket minus cos theta 2 minus plus cos theta 1. Then w is equal to p plus cos theta 1 ಮೊದಲು ತಗೊಂಡೆ, ಆಮೇಲೆ minus cos theta 2. Now potential energy is 0 when dipole is perpendicular to the electric field. ಹೀಗಿದ್ದಾಗ ಅವಾಗ ಏನಾಗಿರ್ತದ, potential energy 0 ಇರ್ತದ, ಅದನ್ನ ನಾವು ರೆಫರೆನ್ಸ್ ಕೊಡ್ತೇವೆ. Or theta 1 is 90 degree. The work is done only in the rotating dipole from position perpendicular to the electric field to any direction, either this one or this direction. That is you said to be theta 2 is theta. Theta 1 is 90 degree. W is equal to PE cos theta 1 cos 90 degree minus cos theta 2. Theta 2 is theta. Now W is equal to cos 90 0 minus cos theta minus PE cos theta. Now work done is equal to potential energy. Therefore potential energy. Therefore U is equal to minus PE cos theta. U is equal to minus vector P dot vector V. This is the equation number 5. Now this is the equation for the electric potential energy possessed by the electric dipole when it is placed in the electric field. Either you form this form or you set to be in this form. Okay, thank you.